Hello everyone, it's me again back to your screens. Welcome back to another beautiful episode of Just Ask Sage. So today we are going to continue our marathon on calculus with the product rule of differentiation. The product rule states that dy by dx is equal to u dv by dx plus v du by dx. We use the product rule when you have the product of two functions in one function. You're asked to differentiate a function that involves product of two functions. Let me give you an example. For example, let's try differentiating this function. Our function here says y equals x squared, then in the bracket we have x plus 3. Now we do know that brackets can also stand for multiplication. So in this case, like a 2-in-1 function, we have the function x squared and we have the function x plus 3 multiplying each other. We have two ways to do this. Either you expand the brackets or you use the product rule. Now let's make use of the product rule. First of all, as you can see from our formula, we have u and v, the parameters u and v. So the first thing you do is to assign your parameters. You name u as one function and v as the other function. So in this case, we'll be saying let u be the first function, x squared. Then our v be the second function, x plus 3. We are going to make use of product rule because it involves multiplication of the two functions. Now, from our formula, we need dv by dx and du by dx. This means that the u and v that you've named, we are going to differentiate them with respect to x. So if we differentiate u with respect to x, that will be giving us our du by dx. Now, in our power rule of differentiation, remember, you have to bring the power down, then subtract 1 from the power. So if we want to differentiate x squared, we'll first of all bring 2 down, making it 2x raised to the power of 2 minus 1, which will actually give us back our 2x. Then for our dv by dx, that means differentiating v with respect to x. You differentiate x. Differentiating x is like x to the power of 1. So differentiating x will give us 1, bring the 1 down, that's 1x to the power of 1 minus 1, plus differentiating 3. 3 is a constant. The derivative of any constant will give you 0. So it is plus 0. So this will give us 1x to the power of 0, which is actually 1. So now that we have our dv by dx, du by dx as 2x and dv by dx as 1, we can substitute into our formula. So therefore, our dy by dx will be equal to, from the formula we have u times dv by dx, that is u x squared times dv by dx 1 plus v times du by dx. V is what? X plus 3. Remember to put it in brackets. Times du by dx. Du by dx is what? 2x. So this means that our dy by dx equals x squared times 1 will give us back x squared. Plus, there is no need to open this bracket, so you just write, we'll bring this 2x to the front since it's multiplying, plus 2x into x plus 3. You can decide to leave your answer like this, or you can decide to expand, whichever you choose. So this is the derivative. Let's expand. So this will give us x squared plus 2x multiplying x, that is 2x squared, plus 2x multiplying 3, 6x. So this will give us 3x squared plus 6x. So this is the derivative of our function here above. Now let's take another example. As we can see here, we also have two functions multiplying each other. So we'll also be making use of the product rule. So in this case, our u is going to be the first function, 2x cubed minus x, And our v is going to be the second function, x squared plus 4. Now, differentiating these two functions with respect to x, our du by dx here will be equal to, remember, here we have 2x cubed. We have to bring down the power 3. So this will be 3 times 2x, then you subtract 1 from the power, raised to the power of 3 minus 1, minus x. X will give us 1 if we differentiate. The derivative of a single parameter without any coefficient will give you just 1. So now, this will now be equal to 3 times 2. This is 6x, 3 minus 1, 6x squared minus 1. This is du by dx. Then for our dv by dx is equal to, differentiating x squared, bringing down the power, this will be 2x raised to the power of 2 minus 1, plus differentiating for a constant. Derivative for a constant will give us 0. So this will be equal to 2x raised to the power of 2 minus 1. That's just 2x. So these are derivatives. Now, imputing everything into our product rule formula, we'll have that our dy by dx is equal to u dv by dx. U, that is 2x cubed minus x, dv by dx is 2x, plus v is x squared plus 4, du by dx is what? 6x squared minus 1. So let me just rearrange this to be too long to expand. So this will be 2x into 2x cubed minus x plus x squared plus 4, 6x squared minus 1. So this is the derivative of this function above. We now know that product rule is used when you have the product of two functions in one function. So now let's move over. Now the quotient rule states that dy by dx is equal to v du by dx minus u dv by dx all over v squared. We use the quotient rule when in a function, the function involves the division of two functions. Remember, product rule is when you have multiplication. Quotient rule is about division. Now let's take this example. Now in product rule, same as product rule, the first thing we'll do is to name our parameters. But unlike the product rule you can name any of them as u and v. You can say the first one can be v, the second one can be u, whichever you choose. But in quotient rule, it is strictly that the numerator must be u and the denominator must be v. It means you cannot say this is v and this is u. No, it is must that u must be on top, then v must be down here. So in this case, our parameters will be, let u be the numerator x squared and v be the denominator x plus 1. So now we are going to differentiate to get our du by dx and dv by dx. So in this case, our du by dx equals x squared. Just bring down the power. Bring down 2. You have 2x if you differentiate this. Then our dv by dx equals, differentiating x, like I said, x is a single parameter. So differentiating that will give us 1. Then plus the constant, differentiating 1 will give us 0. So our answer is just 1. Now putting this into our product rule formula, we'll have that therefore our dy by dx will be equal to v du by dx. V, that is x plus 1, du by dx, that is 2x, minus u is x squared, times dv by dx, 1, all over v squared, that is x plus 1 squared. Now this will give us, multiplying this, you have 2x into x plus 1 minus x squared all over x plus 1 all square. Now I'm just going to be expanding the numerator. So therefore, our dy by dx is equal to 2x multiplying x will give us 2x squared plus 2x multiplying 1, 2x, then minus this x squared all over. I'm going to be leaving the denominator the way it is, x plus 1 all square. So this will give us 2x squared minus x squared plus 2x all over x plus 1 all square. This is our final answer. Alright, so let's take this second example. Remember, u is our numerator and v is our denominator. So this is going to involve quotient rule. So here we'll say let our u be 3x cubed minus 2x and our v will be x squared plus 1. Differentiating these parameters, we have du by dx equals 3x cubed. If you bring down the power 3, it will be 3 times 3x, subtract 1 from the power, this will now be 2, minus differentiating this will be, this is like an invisible 1, bring down the power, this will be 1 times 2x to power 0, and this will give us 3 times 3, 9x squared, minus 1 times 2, 2. X to the power of 0 is 1, so this is still 2. Then for our dv by dx, our dv by dx here will be, here bringing down the power, you have 2x raised to the power of 1, that's just 2x, plus for 1, if you differentiate a constant, it's 0, so this just remains 2x. So putting all these into our quotient rule formula, we have that our dy by dx will be equal to v du by dx. Where is v? Okay, look at v. V x squared plus 1 times du by dx, that's 9x squared minus 2 minus u 3x cubed minus 2x, then times dv by dx. dv by dx is 2x all over v squared. v squared, that is x squared plus 1 all square. So let me just arrange this properly. So this will be equal to x squared plus 1, 9x squared minus 2 minus 2x into 3x cubed minus 2x all over x squared plus 1 all square. So this is our final answer. So guys, this is how we use the product rule and the quotient rule in differentiation. We are going to end this video here today, but in our next video we'll talk about more rules such as the chain rule and the implicit differentiation. Tune in for more videos on calculus, and make sure to try more questions on your own, and do leave a question in the comment section. Sage out.